All right, so in this video we have two more types of angles to talk about before we finish out this section, and it is coterminal angles and reference angles. Coterminal angles are two unique angles that have the same initial and terminal sides. So for instance, let's just sketch a basic angle. Let's sketch a 90-degree angle, a positive 90-degree angle. So the given angle in this problem is 90, and the initial side is the positive x-axis, and the terminal side, in this case, is the positive y-axis. The terminal side can be whatever we want it to be, though. So the coterminal angle has to start in the same place as the given angle, but also end in the same place. But they have to be unique angles, so that's why I'm rotating the opposite direction. And I know there's 360 degrees in a circle, so that means the coterminal to 90 would be negative 270. Now this other note says there are an infinite number of correct answers because technically we can go a full 360 degrees around the circle and then rotate an additional negative 270, and we would still end in the same place. But typically, the answers they're going to be looking for are in one of those two ranges there. And then finally, reference angles. Reference angles are the smallest angle that the terminal side of an angle makes with either side of the x-axis. So we're not going to do an example here just yet, but there's really three things you need to know about reference angles when you're looking for one. Number one, they're always positive. No matter what, the reference angle is always positive. Number two, they're always acute, meaning less than 90 degrees, or, you're going to see this a lot, less than pi over 2. Remember, it's 90 degrees and pi over 2 are the same. And then finally, this is really just the definition in another way. It's the shortest revolution, or sometimes I say distance, to the x-axis. And again, it can be the positive x-axis or the negative x-axis. This definition sounds really complex, but if you remember these three things, it's really not too bad. So now let's work out some examples. This first set of examples says determine the angle that would be coterminal to the given angle that is within this range. The negative 360 to positive 360 range, or in radians, negative 2 pi to positive 2 pi. So we need to sketch the given angle. The first angle is negative 220. So I'm going to start on the positive x-axis. I'm going to rotate clockwise. That's 90. That's 180. So really negative 220 is the same thing as negative 180 plus an extra negative 40 degrees. So here's my given angle, negative 220 degrees. The coterminal angle is going to be the one that starts in the same place, ends in the same place, but basically the quickest way to find it is it rotates in the opposite direction, which means the coterminal angle is going to be positive 140. I know it's positive 140 because 360 degrees is a full circle, and if we take away the given piece, we end up with that answer. But notice, most of these examples will do the way we're answering them. If the given angle is negative, the answer is going to be positive. And likewise, I want you to try B, but if the given angle is negative, that means your answer should be positive. So try letter B. All right, so there's the given angle, negative 145 degrees sketched. That means the coterminal angle again, is going to have to be positive because it starts in the same place, ends in the same place, but rotates the opposite direction. So to get our answer, just take 360 minus 145, and what is that, 215? Now to do radians, it's essentially the same thing. The only difference is they want their final answer in radians. So if it's helpful, we can write, okay, this is 0 pi, 90 degrees is equivalent to pi over 2, 180 degrees is 1 pi, 270 degrees is 3 pi over 2. So you want to get to the point where you kind of know those quick conversions. So negative 2 pi over 3, negative 2/3. Think about where negative 2/3 would fall in here. And actually, since it's a negative angle, you can make the case that we should probably change these. This should be negative pi over 2. This should be negative pi. And this should be negative 3 pi over 2 up here. So negative 2/3 is a little bit bigger than negative 1/2. So negative 2/3 would be somewhere in quadrant 3 right there. Which means the angle that's coterminal to negative 2/3 is going to be this angle coming from the opposite direction, which again is going to have to be positive. But we know those two angles add up to 360 degrees. So the quickest way to get the answer is to do 2 pi, or just 2 minus 2/3. So we can rewrite this as 6/3 minus 2/3, which is 4/3 pi. You can also use the strategy of converting this 2 degrees and then getting the coterminal angle that way, but you have to remember to convert your final answer back to 4/3 pi. So it does end up creating more work for you doing it that way. And if you're going to pre-calculus next year, I would encourage you not to use that method. I encourage you to try this last one, try letter D, pause the video, and I'll work it out in just a second. All right, so 5 pi over 4, that's the same thing as 1 and 1/4 pi. If it's helpful, you could rewrite it that way. So this time it's a positive angle, so 1 and 1/4 is going to be a little bit more than 1 pi. So 5 pi over 4 would be somewhere there in the third quadrant. The angle coterminal to that is going to have to be negative, since we're going the opposite direction. And the quickest way to get that, I'm going to put a negative sign because I know it's going to be a negative answer. Quickest way to get that is a full circle is 2 pi radians. So I'm just going to take 2 pi and subtract 5/4 pi, or in other words, 8 over 4 minus 5 over 4. And there's our answer.